Chapter 3 Review, Graphing Linear Functions. Don't forget, we have a test on Thursday or Friday, depending upon which day you are in school. Okay, to determine if a relation is a function, we have a set of ordered pairs. You can just take and plot the ordered pairs on a coordinate grid, and then see if those ordered pairs will pass our vertical line test. And we never have more than 1 point on this vertical line at one given time. So this one is a function. The second one over here, if I plot those ordered pairs, a couple of them are off my grid, but it will also pass our vertical line test. So it is a function. And just for example, if I would add another point right here, this graph no longer passes the vertical line test. So this one would not be a function. And now for linear, continuous, and discrete functions. Okay, now to determine if these are linear functions or not, since this problem is in the form of y equals mx plus b, it is a linear function. Now number 4, my change in x through this whole table is consistent, but my change in y is not. That's plus 4, plus 5, and so on. So since my change in y over change in x is not going to be consistent through my entire chart, this one is not linear. Okay, for this problem, to determine whether the domain is discrete or continuous, since we cannot use a partial table, this is going to be a discrete function. The number of tables will not be continuous because you cannot have 2.9 tables. For this problem, this one would be continuous because even though we took the age at 1 and then 4, you're still age 1.1 or 1.9 or 3.8 in between there. Now we will evaluate functions. Okay, to evaluate functions at a given point. To evaluate f at -2, we substitute -2 in for the x on the function. And then we can go through and evaluate 3 times -2 is -6, plus 1 is 5. And we can do the same thing for f at 0. We have 3 times 0 plus 1, which is 1. And our f at 3, 3 times 3 plus 1 is 10. And to take the second function of h of x, we can substitute -2 in for x. And here you have to be careful because now we're going to have 6 minus -4, which turns that into 6 plus 4, which is 10. And h of 0 gives us 6, and h at 3 gives us a value of 0. And similarly, now to set a function equal to a value, so to set this function equal to 30, we now set 5x equal to 30, divide by 5, and we know that x equals 6. And we can check this answer because if I take 6 and substitute that in for the x, 5 times 6 will give us 30. Same idea over here. Set that equation equal to 9. Okay, when we set this equation equal to 9, we have to subtract 4 on both sides. And when we have 1/5 x equals 5, we have to multiply by 5 on both sides because 1/5 times 5 equals 1. And we're left with x equaling 25. And if I substitute 25 back in for my x, 1/5 times 25 is 5. plus 4 is 9. And now for graphing equations. Yes. Okay, to graph equations that are in the form of ax plus by equals c form, that's when we set up our chart and we substitute 0 in for x and 0 in for y, and that will find our x and y intercepts. When we plug 0 in for y or for x, we get 7 times 0 plus 4y equals 28. That leaves 4x equals 28, so x would equal 7. Then when we substitute 0 in for y, we have 7x plus 4 times 0 equals 28, which is 7x equals 28, and x would equal 4. Now we can put those 2 points on our graph, 0, 7, and 4, 0, and draw a line going through those 2 points. And we have our graph. For our second equation, this one is in the form of y equals mx plus b, where b is our y-intercept and m is our slope. Now, our y-intercept in this case is -2, but our slope, which is change in y over change in x, is 2/3. So the first thing we do for our graph is use your y-intercept of -2. And then we can use our change in y of 2 and change in x of 3 and keep drawing our next points. Now remember, for this, we can also use a slope of -2 over -3, since that also equals positive 2/3. So we can go down 2 and left 3. So we're doing -2 and -3. And those points are on the same graph. So after we have our points, we can line up our graph. Now for the next problem where x equals 3 at this point, but x also equals 3 at this one, here, here. X equals 3 anywhere on that line, which makes that a vertical line when we do our graph. And the vertical line, just so you know, we'll practice it again on the next problem. The slope is considered no slope or an undefined slope for a vertical line. And that is because if I have a chart where it's showing a vertical line, like we just got done graphing, my change in x here is 0. And my change in y, in this case, I have it set up as 3. So that means my change in y is 3, my change in x is 0. Division by 0 is undefined in mathematics. That's why we end up with the 0 slope. For this problem, since it's in the y equals mx plus b form, m is my slope, so my slope is equal to 8, or 8 over 1 if we want to write it as a fraction. Now, y equals 3 is a horizontal line, and a horizontal line has a slope of 0. So once again, a vertical line is no slope. A horizontal line is 0 slope. Okay, I'm going to change problem 17 and 18. I'm not going to have transformations of linear equations on your test. So I'm going to give you a couple more practice problems for 17 and 18 on graphing. So go ahead and graph these two linear functions. Now for this first linear function, it is in that form of ax plus by equals c form. So we're going to take and set up our chart where we plug 0 in for x and 0 in for y. 0 in for x leaves us with y equaling -6, and then substituting 0 in for y leaves us with x being -4. Those 2 points on our graph, and we can draw our line. For the next problem, it's in the y equals mx plus b form. So our y-intercept is -3, and our slope is -1/4. So -3 or our y-intercept. And now for the change in y over change in x, make sure you only do one value negative. The other value will be positive. So -1 and +4. Or we can do -1 and her +1 and a -4. Works also. But you can only do one number negative. And we can draw a line. And now for graphing more equations. Woohoo! Now for transformations of absolute value functions. Remember when the number is outside of the absolute value mark, that's going to shift this problem down 5. So my new graph or my parent graph is going to shift it down 5. So it shifts along the y-axis. Now when I have the value inside of the absolute value marks, remember that's when the inside equals 0. So in this case, that would be at -4. So that is going to shift this graph to the left 4 places. Didn't quite get 4 places. There we go. And then for the bonus question, I'm also changing that one up. It just put several transformations in there. For this one, it's going to have a shift of +4 and then up +3. And this 2 is going to make our graph stretch up. So here is our parent. We're going to shift over to 4 and then up 3 and stretch it. And our new slope is 2/1. But that's a bonus question. That's it for your review. Don't forget your test.